In this video we're going to take a look at the Forget Me Not challenge on HackTheBox. It's a medium forensics challenge and the description says, don't forget to totally forget me. So let's start by downloading the files. And we'll copy these over. And see we've got two archives here, 7-zip and a zip archive. Forget Me Not and kernel. Let's copy these over here and enter in our password. And we've got some more extracting to do here as well, so let's do that before we do our basic file checks. So we'll unzip kernel. We now have a module and system.zip. I'm going to remove the kernel.zip and I'm going to unzip module. I'm going to unzip system. Skipped path components in, okay. We'll unzip system here, so we've got a module.dwarf file from the modules.zip and we got a system map generic file from the system.zip. Let's remove the zip files then, remove all.zip, and let's 7z extract the forget me not. It's taking a little while. And now we have deep memory there as well, so let's remove our forget me not 7-zip archive and let's see what we have. So we have a boot folder with system.map generic in it, we have a deep memory file, and then we have this volatility file structure with module.dwarf in there. So let's check the file type of deep memory. It just says it's data, a large file. Let's check for the strings. We'll do strings-n10 deep memory. Alright, you can see we're flowing right through the memory dump there. It's going to be too much for us to really do much. We could try to grep out HackTheBox, HTB. You can see some IP addresses here, 10.10.10.158 /JSON. This is the address range that are used in the HackTheBox machines. Maybe it's something to do with that, I'm not too sure. But we could mess around with that to see if there's any flags lying around, but let's not. Let's investigate the boot folder. We have this file system.map. It's ASCII text. Let's do strings-n10 system map. Okay, and we can see we have addresses here mapped to functions by the looks of it. Why not try to grep HackTheBox as well? Nothing. Okay, let's go back. Let's see what we have in our volatility folder. Tools, Linux, and then we have this module.dwarf. So file type, ASCII text, very long lines. Okay, strings-n10 module.dwarf, and it looks like some other kind of mapping here. Again, why not just try to grep out HackTheBox? Nothing of interest to us. So we're going to have to try and do a little bit of research into what these files are and what they might be able to do for us. So one thing of particular interest to us is going to be this dwarf file. We can see it's got the volatility, it's inside the volatility tools Linux file structure, so that gives us a hint that we'll be using the volatility tool anyway for this challenge. Let's try and Google module.dwarf volatility and check out the first link, how to generate a volatility profile for a Linux system. When you start analyzing a Linux memory dump using volatility, the first problem you may face is choosing correct memory profile. In my opinion, the best practice is to generate your own profile, okay? And a Linux profile is essentially a zip file with information on the kernel's data structures and debug symbols used by volatility to locate critical information and how to parse it once found. Process generation is a simple process, so here they get an updated copy of volatility. They go into the tools, Linux, and then create module.dwarf. And this is gonna, using a specific tool provided from volatility, okay, and they're gonna make a zip file containing module.dwarf and then the debug symbols from system.map. So we also had this system.map in the boot directory. And what they're doing here, they're doing zip of the LSB release. They're just creating the name of the zip folder, and in the zip folder they're passing module.dwarf and the system map, the boot system map. Okay, so that was actually the file that we had there. So maybe we needed to keep it inside of that zip file and inside this structure. They say then finally copy this zip over into the plugin path on your forensic workstation, usually volatility/plugins. And this can be all wrapped up into a simple bash script. Okay, let's go back again, just have another check. Volatility, dwarf. What else do we have here? Let's check this one as well. And this is, again, these are describing how to actually generate module.dwarf. So we already have all this put together. What we really need to know is how to use it. So we have the zip file. It's saying copy the path of the zip file into volatility's plugins/overlays/Linux directory, and then confirm that the profile loaded correctly. Here we have, so they've suggested to locate overlays, grep Python, grep Linux. Let's try that. We have this for recall or recall. I don't even know what that is. Let's have a look. Memory forensics framework. Okay, it doesn't seem to be the path that is being used here. This is Python 2. Now note that I don't actually have the Python, the volatility repo installed. If we do volatility, let's just do volatility at 2.6, and it's just from the sudo apt get install. We don't actually, let's locate volatiliy. So we have it here in this local directory. We do have this for PyPyCats, but it's this is our volatility user local bin volatility. So there's no actual plugins directory. Let's go back here. Let's create this first of all, the profile. So if we let me keep this open so I can kind of see what's going on, and we'll do zip. I'm just going to do profile.zip, and we're going to give it the volatility tools Linux module.dwarf, and we're also going to give it boot and then the system map generic. Zip up that profile. Now we have the profile there. The issue is just supplying this profile, usually in volatility/plugins. Let me just search for volatility plugins Kali Linux. I'm not using Kali Linux, but typically the solutions for Kali normally seem to work for my Parrot OS as well. Let's have a look at this. Okay, this is dash. Okay, so this is just to help additional plugin directories to use. Okay, so we might be able to do that. How to add Linux profile. Okay, so it's written in the usage. This is what we've just done. We've done sudo. We didn't do sudo. Maybe we need to do that. So we did the zip. Or that might just be so that you can access the system map from boot. I don't know. And yeah, the path doesn't exist. It might be under Python. It's not, because we have. So you can do this sudo update and sudo locate, but it's not gonna. It just gives us the user local bin volatility, so that's not much use to us. Alternatively, you can put the plugins anywhere you want and specify them with dash plugins. Alright, let's try that. Let's just go back here and actually check this link. Specifying additional plugin directories, so we can specify directories dash plugins. We can also specify a zip file containing plugins, such as, and this is what we'd need to do. So let's try that. We'll do volatility dash plugins equals profile.zip. Let's try that. We need to do something. Dash dash info. And here we have all of our plugins, our scanner checks, address spaces. Here's our profiles. So let's see here. In this example, they've done dash dash info and then grep Debian, and it's because it's added their new profile. What if we... So let's run that without the... We'll run it without the plugins zip archive. We'll save it to without profile. We'll do the same thing again with the plugins directory selected, and then we'll do that to with profile. And then we'll just run a diff on without profile and with profile. There's no difference at all between them. So that didn't work for us. Let's remove that. Remove without and with profile. Okay. What I'm going to do, I'm going to retrieve the initial archive that we used there. Okay. Let me grab the kernel.zip. And kernel.zip contained module.zip. Okay. I don't think this is going to work. I think these needed to be... I don't think these needed to be separate archives, but just out of interest, let's try and run that with kernel.zip. And we'll just print it out and see if we see anything differently. Any new profiles here? We're expecting probably to see a Linux one. And there doesn't appear to be any difference there. Alright, let's remove that. I think the profile here is right. Okay, let's do a bit more research into this. So I'm going to search here for module.dwarf CTF write-up. See if there's any similar previous challenges that we can take a look at. I see one here, Sharky CTF from 2020, or it was written 2020 anyway, and identifying a machine. Let's see where dwarf is first mentioned. Dwarf, okay. Creating a volatility profile, building similar. Okay, so they've done. Let's check what they're doing here first. Is grep a boot image. Although we're going to do that from our, what's the name of our file? Deep memory. So we'll do this from deep memory. Boot image, and we have this VM Linux generic root. Okay. Grep a Linux version, but from our deep memory. Linux version 5.0 generic, okay. Grab that in case we need it. And then the Linux release as well, okay. We didn't find a Linux release there, but let's open up Sublime and keep hold of this version in case we need it. Creating a volatility profile. So we already have a volatility profile. Next step was to build module.dwarf. We have that. We don't need to worry about that. And here they do that exactly. They zip up the create a zip containing module.dwarf and the boot Image. Okay, yeah, looks the same as we have here. Let's open up our profile.zip. We have volatility. Does this need to be all in one directory maybe? Because in this example they just have module.dwarf and then they have the system image boot system map in there. In order to be taken into account, it must be then placed into volatility plugins overlays, which we don't have. And then this should show up. Alright, just one other thing we will try then is to just create another profile. Let's go back to our let's copy volatility tools module.dwarf right here, and let's do a, I don't think we should need a sudo zip because we're just dealing with a local boot here, but I'm just going to do sudo just in case this was causing an issue, and we'll call this new profile.zip, and we'll pass it the boot system map, and then we'll pass it module.dwarf. And then I'm just going to try and run volatility again with our new profile.zip and just see if we have any new profiles shown. It doesn't look like it. No, we need a Linux profile to show up here. So that's not working for us. Okay, so I think the best thing to do here will be to try and just download the volatility GitHub repo and install that so that we have the overlays folder. Every guide that I've seen using this module.dwarf has used that folder, and for us obviously maybe there is a way to get it working with just a standard Debian install, but it doesn't seem to be working for me. So I'm going to download this and try it out. I'm going to make a new directory, temp, because we already have a volatility directory here, and hopefully this doesn't really cause any problems with the volatility package I have installed with the apt-get. Let's go into our temp directory. I'm going to also activate the Python environment. So source, I just have an alias set up to activate this. pyenv2, just because we might have to install some packages here, and I don't want to mess up any other things, because I'll probably just go back to using the volatility that's installed on the system after this. Okay, we've got that activated. Now let's do git clone this into volatility. I'm going to go into volatility and I'm going to do python setup install. You can see it's going through. It's actually, you can see that it's doing plugins overlays, which sounds pretty good. Looks like we're at least going to have the directory that we're hoping for. Alright, let's now that's done, let's do update db. Let's locate overlays. And you see we have a lot more now. We now have our volatility overlays. You can see all the different Windows ones here. So presumably these are all just built in with the Debian release, I don't know. But okay, so the overlays, we want it in the Python site packages though, right? So let's go Python site packages. I'm gonna copy // profile.zip. I'm gonna copy it to our overlays here. I think this is, let's go and see what these guides had. Too many windows open. Too many windows. Okay, they placed it in volatility plugins overlays Linux. Let me just see if we had anywhere else to place that. Not inside this py2 egg. You see, it might just be in here. Okay. Yeah, I'm going to try it in here first of all. me remove this. We'll copy it to there, and then Linux. And now let's try and run Python vol.py --info. See, we're getting some errors here. Failed to import volatility plugins. No module named crypto.hash. Do we have any new profiles? Oh, we have a Linux profile, x64. Awesome. Let's try and fix these issues of volatility plugins, no crypto hash, distorm. So pip install, let's try this. Distorm 3. That didn't look too good. Same error, okay. Let me try the crypto one. Pip install pycrypto. Not good either. Okay, fingers crossed this is these errors aren't going to cause us problems. Maybe it did show up with the profile, so what if we try to run volatility -f and give it the file, which is what's the file name? Deep memory doesn't show up here. Deep memory, and then -- profile equals. Let's grab this profile name. The Linux profile seems to be the only new thing we have there, and then we'll say image info. Does not support the profile. Okay. So maybe it's an issue with the profile, maybe it's an issue with these missing modules, or maybe it's an issue with the image info command. So let's see, in the example that we were looking at, from the previous CTF, they used Linux bash as the first command. So let's see if Linux bash works. Okay, it's not giving us any errors so far. It looks like it's that is working. Okay, we can see they went into the documents. We have a hash here. Let's run hash ID. It looks like probably an MD5 hash then. Yep, dev md5. Okay, let's go to crack station. We could use hashcat or John or something, but it's probably going to be quicker for us to do this. Although, having said that, the amount of time it takes to actually load up the capture here might actually make it slower. While we're doing that, let's see what other commands might have been run here. Okay, they didn't run any commands that got them the flag. Hopefully it gets us the flag as well. Let's see. I'm not a robot, but I'll do some machine learning labeling for you anyway. I know how crucial it is to identify all the chimneys. Crack the hashes. Not found. Okay, not good, not good. Let's go to CyberChef. See if we can do any magic on it. Magic. No. Okay. So there's no real indication what that would have been used for. Well, I guess the important thing is that we are able to use this profile and run some commands. So we might return to this hash later. Let's see if there's anything else we can do with any other commands that we can run here. So I was just playing around with this a little off camera, and the error message was driving me crazy. This all these plugin imports. So I tried to install the PyCrypto and Distorm 3 again, and got these same errors to do with, where is it? Where did it trace to? This missing the Python header in fast math. So to solve this, I installed Python 2. Python dev -is Python 2, and then that allowed me then to do pip install on those. So now if we try and run this again, let's I'm going to do the Linux banner one. We're not getting any of the plugin errors, which is good. So we can see here Linux version, and it's given us all the information. Ubuntu 8.3. So we could potentially find, I guess, a profile using this rather than the custom one. But let's now go back to the help section and see what other commands we can run here. Okay, so I actually spent a while flicking through some of these commands and trying them out and seeing what we could get working. Let me just give you an overview of the things that I tried. So I tried these bash commands, check creds. Didn't bring back anything particularly interesting. This enumerate files was more useful. This retrieved a lot of files on the system. I'll let it run through a little bit here just so we can see it start to flood through, and then I'll show what I did differently as well. We can check the net scan, so we can look at network connections. Similarly, ifconfig, our current working directory. We can check the process list and process tree and things like that. So I spent a good while going through this stuff, and you'll see this starting to flick through now. It comes up, but you can see how many entries this has. So essentially I decided to do this but focus on the Volamos user, which showed up towards the top. Let's go back up here. So these are likely to be directories and files that have been created by the challenge creator, as it's in their home directory. Let's keep going. There we go, yeah. So these files here. So I decided to basically focus on these files, and because there's not really too much to focus on here, I figured that the Firefox profiles would be the best avenue to go down. So I was trying to extract these files, so you can, for example, I tried to just carve out the entire folder, but even just selecting individual files, even if we say like let's grab the cookies. So the cookies you can do then, let's do this -h again. I just grabbed the address there, and we could then use, now that we've used the find file, we used enumerate files there, so we can also use this find file. So let's say Linux find file -h. It'll give us some possibilities, our options here, and we can say that we want to find by the path, or we want to find by the inode number, or by the address. So right here we have our address, we have our inode number, and then we have the path. So if I want to just, let's go by the path, and find file -F, and then we paste in the file, and then we should be able to output that as well and say cookies.sqlite. I'll just call this new, and just let that try to find it. So I kind of figured that, similar to a previous challenge, we might need to grab the Firefox files and then crack the master password on that, if there is one, to decrypt the database. But that didn't work for me. We'll get to see here. Just while that's running, let me just note as well that if we go back to our deep memory, to our memory image here, and do strings -n, we'll just do strings on it, deep memory, and then try and grep I'm going to say grep HackTheBox HTB, you'll see how many things flood in here, because it looks like this box was used to try to hack some of the HackTheBox machines. You can see the registry machine there, and if you go through a lot of this, you can see that it looks like it's been used to actually. So I don't know whether that's been done on purpose, just to try and obfuscate the image, or whether this is genuinely a Linux image which was used to solve the challenges, and it's just all this stuff's just been left in here. But it does make it a little bit difficult for grepping through. I also tried to just grep through and find like HTTP stuff and see what kind of URLs we have in here. And again, you'll see a lot of 10.10, you know, a lot of the HackTheBox URLs and other hacking sites, so hacking challenges. So yeah, I'm not too sure whether that's done on purpose, but it does make things a little bit more difficult. You see, if we go back to our find file here, you can see it has the inode number, it has the inode here. So this is the number, this is the inode or the address, and this is the file. But if we then go to cat new, it didn't even give us a new. So this was basically the issue, that I wasn't able to extract these files, and I spent a good amount of time researching this and trying to look through volatility documentation to see how else we could actually extract the files. I also tried, let's go back to, let's do -h again. There is there's a function here, Linux, not I tried this tempfs one, but there's also recover file system, which I tried to do. If you run recover file system, it'll actually try to recover all the folders that you see there, but it fails to recover the root directory and the home Folemos directory. So actually it fails to do that. So I think that's basically that's me very briefly covering the things that I wasted a lot of time on. Now I'll go into how I actually finally solved the challenge. So after a while, I returned to the Linux bash to get our bash history, because the only previous CTF challenges that I could find, any write-ups, all kind of focused on the Linux bash history. If they, you know, because there's so little challenges that actually use this custom Linux profile in volatility, you know, as an intended solution. So it went back to focus on this. I'd already tried to crack the hash on it in a couple of different locations. I'd also just tried googling the hash to see what was going on. I couldn't really find anything of interest. So I basically left it at that, but figured that we might need to return to that at some point. So eventually what I did find, let's go to, let me grab this URL, the HackTheBox, the hints section on the forum. So a lot of people seem to be struggling with the challenge, and somebody had suggested that, yeah, you almost certainly overlooking it. I did it for days on end because it's not obvious, and other than frustration, I can't see why you would try to do what you need to do. There's no obvious reason to do it. So I mean, this is kind of unfortunate. I don't like challenges that don't have an obvious route to solving. So what they had suggested here is don't just put things into Google. Look at other platforms you might consider as an incident responder. So instantly the first thing that jumped into my head was VirusTotal, and if we go to VirusTotal and paste in, we can go and search, and we can search in here for URLs, IPs, domains, or file hashes. So let's grab the hash from the bash history, and if we submit that into VirusTotal, we very quickly get this flag. And yeah, that's how we solve this challenge. So I wasted a lot more time than hopefully you will do if you watch this video. And I would say, if you have any tips on how we could have solved this quicker, let me know. But I don't really think there is much we could have done to solve this quicker, aside from knowing to go and check VirusTotal for that hash, and obviously, oh yeah, if anybody knows why how to load the custom profiles into volatility, that's just already that's installed through apt-get rather than the Python rather than the GitHub repo. I'd be interested to know how to do that. But yeah, I hope you've enjoyed the video anyway. Any questions, comments, leave them down below. Thanks.